Hello, welcome again. We are going to solve a problem in forces, and today we have a question that reads: a particle is acted upon by the following forces. So you can read it from your screen. 20 Newton force inclined at 30 degrees to northeast, 25 newtons inclined 90 degrees northwards, 30 newtons inclined 45 degrees towards north towards west, 36 newtons inclined at 60 degrees west towards south. The question says that we sketch the system of forces on a space diagram and determine the magnitude and direction of the resultant force. So in such a question, we are not given to do it either in in two ways, that is by resolution, that is either to vertical or horizontal component, to its vertical horizontal components, that is after sketching it, after drawing that sketch, that is the space diagram. And number two, we can as well approach this question by graphical method, that is by sketching the space diagram and putting it in form of a graph, considering the scale and of course the scale depending on the magnitudes of the force that you have. Now, in our previous video, we did a lot concerning resolution of forces, so you can tune to our video on resolution of forces to vertical and horizontal components. Today we're going to solve this question specifically using graphical method. Now let's go. So from the understanding of our question, it tells us at least we have Cartesian as that, and this is the north, south, east, and west. So in between here, of course, there are angles. Now we have the first force, that is 20 Newton force inclined at 30 degrees. Now remember, we are moving from inclined at 30 degrees, it's northeast. So in between here is northeast. So it's not towards east. So we're reading it from north. So we are going to incline this force of 20 newtons in 30 degrees towards north. This is the northeast, remember. So this in this direction. The force number two is 25 newtons inclined at 90 degrees northwards. So from the north we have 25 newtons towards the north. So it's a Coplanar force. 30 newtons inclined at 45 degrees north towards west. So can you see our north towards west? It's in this direction. So north towards west 45 degrees, we have a force of 30 newtons. And so indicate the angle. And lastly, we have 36 newtons inclined 60 degrees west towards south. So from west to south, that is 60 degrees, and we have this force of 36 newtons. So we have 4 forces. Now I want us to draw the same figure, that is using our protractor, and get to identify, be specific, or rather be very much accurate in indicating the angles, because in the method that we're going to apply, we're going to get the parallelism, or rather get a line parallel to each and every force. So please do the same. Get your pair of compass and indicate a force. Don't mind of the scale, just the way it is, but be accurate on the angles. So I hope you've drawn your Cartesian. You can have a look at mine. That's my Cartesian plan, and this is the north. Now we're going to copy our diagram the same way that it is, indicating the angles of 30, 45, and 60 here with the same forces. So you can work with me. Look at the way I'm placing my pair of compass. This is the north. Now we need an angle of 30 degrees from here to give us the 20 Newton force. So 10, 20, 30. So my 30 is somewhere here. I'm putting a dot. Can now proceed and draw that force. So this is my 20 Newton force, and the angle here is 30 degrees. Do the same. We had a force of 25 towards the north, so we don't need to measure that. Just indicate here 25 newtons. And for the 45, we're reading it from the north, so bring in your protractors that. So we are now going to our 30 Newton force. It's inclined at 45. So from 90 towards the north, 1, 2, 3, 4, 45 is here. That is it. So you can draw that line to indicate that particular force. So indicate that this one is 30 newtons and the angle of 45 degrees. So we also have this other force west towards the south, and it's inclined at 60 degrees. So this is how we draw it, like that. So from the west, this is our west, 60 degrees. This is always 0 to 60. Somewhere here. Draw that force. So this is 36 newtons at the angle of 60 degrees. Now, please be very much careful on what we are going to draw next, because we now need to identify our scale. So remember, we have a force of 30, 25, 20, and 36 newtons. So get a suitable scale that can be able to fit your paper for all these forces. In our previous drawing, we just indicated you are perfect on our angles. Now, please get a suitable scale, because we are going to draw that using a perfect scale. So for my case, the suitable scale that I'm going to use for my drawing is that 1 centimeter would represent 5 newtons. So I don't know whether you've determined one for your own. So for my case, if 1 centimeter will represent 5 newtons, that tells me that for the 36 newtons, I'll measure 7.2 centimeters. So, and this would be 4 centimeters. This would be 5 centimeters, and this would be 6 centimeters. So if you have a problem in that, please, you can have a look. If 1 centimeter represents 5 newtons, then you can say, now how about, let's say, 20 newtons for my case. So just for the sake of those of us who have a challenge in this is 5 newtons. So this would be 4. So you'll have a scale of 4 centimeters. So the moment you measure 4 centimeter length, you'll be indicating 20 newtons. Good. Now, there is something, at least I think you have observed in our diagram. The 20 Newton force is inclined at 30, and 36 Newton force is inclined at 60 degrees. Now, if you look at it very carefully, the two forces are in straight line. Here, the two forces are in straight line. Now, for such a force, this is like a tensional force trying to stretch a side, and this is of 36 newtons on the negative side. Let me put this 20 newtons towards the positive side, and 36 newton on the left hand side. So because the two forces are tending to stretch apart, they are stretching apart, so we'll have to subtract them. If we are assuming this is our 0, this is our 0, and this positive side, this is negative side. Now, this would be 36 minus 20 to give us 16 newtons. 16 newtons. That tells us our 16 newtons will act on side of 60. Now, get back to our diagram. 60 and 30, 20 newtons here and 36 newtons here, and they are stretching. So we get the difference of the two, and that we will have to remove the 20 Newton force and replace 36 Newton force with 16. So this will now use our new value here as 16 Newton force inclined at 60 degrees. So we do away now with the 20 Newton force. Hope you've marked that. Now, we are now going to draw our forces and we'll indicate the 25, the 30, and 16. 25 Newton force, remember it's acting upwards. Now, from a point, we're going to transfer this force and draw a force parallel to it from the point that we have shown. So this is how I'm going to do it. We want to transfer this force and draw it from a point down here. So how to draw a force parallel to a point, that is it. I want to be very much accurate. Good. So our 25 Newton force, what was our scale? For the 25 we are supposed to measure 5 centimeters. So from this point, 5 centimeters. 5 centimeters. So that is my 5. And this would now be the head. So this is my 25 Newton force. This is the tail and this is the nose of this vector. Now we're going to transfer again the 30 Newton force, which was inclined at 45. Look at how I'm placing my ruler. Remember, we need this force, we need to draw this force from the nose of our previous vector. So I'll have a line parallel to that. I'm going to slide it. So the line I'm going to draw here is a vector of 30 Newton force from the nose. So that is it. And from our scale, we were doing 1 to 5, so 30 I'll have to measure 6 centimeters. 6 centimeters. So from our 0, from my point 0, the nose of that vector, to 6. I hope you're following from your diagram. So that's the nose of my vector. So you can indicate this as 25 newtons. This is 30 newtons. Lastly, we'll have this force of 16 newtons. Now, previously I had not indicated that because we had not realized that this force is parallel, or rather in straight line. So for the 16 Newton force, in our scale, we will have this as 3 points. Centimeters. So using the same procedure that we did initially, we want to transfer this force, or 16 Newton force, the other one at the base, and then we're sliding this line to the nose of the other vector. Slide that. That is it. Then can go ahead now and draw. So we're measuring 3.2. 3.2. So 1, 2, 3.2. So this becomes the nose of my last vector, or that force of 16 newtons. Remember, we were told to find the resultant. Now the closing side, now we're going to draw from the nose of this vector to the tail of the first vector. So this would be our resultant. Put it in dotted. Direction. So this would be our R, or the resultant force. Go ahead and measure using the suitable scale that you add. Remember, the scale will still remain. So I'm having 8.2. Let's be very accurate. So this is 1, 2, 3, 4, 5, 6, 7, 8. Oh, 0.5, 6, and 7. So it's 8.7 from our reading. So 8.7 centimeters. And our scale initially, we were using 1 centimeter to represent 5 newtons. Now for 8.7, now say how about 8.7 centimeters? So you cross multiply that, you'll have 8.7 centimeters. You multiply by 5 newtons and we are dividing it with a centimeter. So we'll have that, and this would give us, so we have this value as 43.5 newtons. So the magnitude of the resultant of that system is 43.5 newtons, indicated as that.